All right, so as we continue section 1.4, we are determining inverse functions, so functions of f of x. F to the negative 1 of x is the inverse. We talked about this yesterday. Graphically, we saw that graphs of inverses are really just reflections about the x equals y, or the y equals x line, right? They're just reflections. So we have to determine equations, and we're going to have to refresh ourselves on completing the square, okay, from last year, I guess. You guys learned how to do that? So here's two examples, okay? The first example over here on the left is where we've reversed the values already. We've reversed the values, and we're going to try and solve for y now. So this one you're going to see is not going to be too bad because y is really just in one place. So this is how we solve for y. We're going to isolate y, and when we get to this point, we're going to have to take the square root of both sides. So that's going to be plus or minus square root of x minus 4 on this side. And then that's just going to be a y minus 2. And then finally, we add 2 to both sides. And so y really is made up of two separate functions. Notice this plus or minus. Okay, really it's y equals root x minus 4 plus 2, and y equals negative root x minus 4 plus 2. Oops. And I'll explain that more. Actually, I'll take the time to explain that right now. If you recall, okay, so this is if this was y equals x, the original function here, right, would be a parabola that has a vertex at positive 2, 4. So the vertex would be about here at 1, 2, and 1, 2, 3, 4. And it opens upwards, right? So it kind of looks like this. If we take a look at the inverse, we know graphically that the inverse is going to be a reflection of that line. And I'll do it in red here. So the inverse, all these points are going to be, reflections, right? And it's going to look something like this. The inverse is going to look like this, okay, roughly. Now, this is not a function, right? Because the horizontal line test passes through twice on the original graph. So the inverse is not a function. So when we have something like this, and you have like plus or minus, that really means two different things, plus or minus. And so this is like a half of this inverse. This one right here would be like the positive half here. You see? That's actually a function of y, but it's only kind of from here on. And this one down here is the negative half. This is the bottom half. So together they make the inverse. But it's two separate functions that we have to kind of piece together, the top part and the bottom part. Now, if that's going over your head a little bit, we will revisit that, okay? We'll revisit that a bit later. But what I'm trying to tell you that if you have a question like this, where you have a parabola and you're asked to find the inverse function, it's going to be easy to find y, to solve for y, when it's in the vertex form. Because over here, this is another example, I'm just going to make some space here. Over here, this one is not in vertex graphing form, right? So the y, we've switched x and y, and the original function here was y equals x squared plus 2x plus 7. Did everyone see that? So when we switch the values, it's like, okay, now I've got the y in two different terms. How do I just isolate for y? We're going to have to complete the square. So we're going to have to remember how to do that. And just so you remember, let's go over it. So what we want to do is we want to take the two y terms here, and we want to write them together. And we want to try and make a trinomial that's a perfect square trinomial. Okay? So we're going to add a term here to make this a perfect square trinomial. And of course, if we just go ahead and add something to an equation, we have to either add something to the other side to make it still equal, or we have to subtract the same thing from the same side. Okay, so hopefully you're remembering this. If not, please look up completing the square videos from Pre-Calculus 20, because we spent a lot of time on that. So as we continue here, this is going to be now y plus, let me finish this. So half of 2 is 1, squared is 1. So we've added 1 inside here, so we need to subtract 1. So to complete the square, we do y plus the number here. It was a positive 1 that we squared, so that's the number that goes there, the number that we squared. And then over here we write this as a combined term over here, so plus 6. Okay? So now we're at the same stage as we were over here, right? So this is now in the form that we can actually solve for y. So just that little step of completing the square first is how we can make it easier to solve for y and express the inverse function as an equation here. So, I mean, it would be x minus 6, right, equals y plus 1 squared. Take the square root. It's going to be plus or minus the square root of x minus 6. And over here is going to be y plus 1. And then, of course, to finish it off, we subtract 1 over here. So that would be, there's 2 parts to this. Again, this originally is a parabola, so we've got a kind of an upper arm and a lower arm pieced together to show the inverse. Okay? Now, completing the square is just a piece that you have to do before you solve for y. When you have an equation for a parabola that's in standard form. Okay, so you may have to complete the square. The question that you're going to do on your assignment that mirrors this is number 10, and so there's number 10 that's in your assignment, and it's given you're given the original equations in standard form. So you have to complete the square, then solve for y. Now the book will tell you, and don't get confused here, it says determine the equation of the inverse by first rewriting the original function in this term. So what I did up here was I switched x and y first, and then completed the square. Either way, it doesn't matter. You can complete the square first, and then switch x and y. It doesn't matter. It's the same difference. Okay? So until you now get some practice with number 10, this still might be a bit fuzzy, but hopefully this example is going to help you. Remember, if y is by itself here just in one spot inside this term that's a binomial that's squared, you can solve for it. If it's in 2 spots like this, 2 different terms, you can't isolate y there. You have to change the form. Okay? All right, so that's part 1 of part 2. There is one more thing I want to show you. And you're going to get a question like this, and it says, how could the domain of the graph of f of x here be, now this is maybe a new term, be specified, or be altered, or be more specific? So how can we narrow down the domain or be more specific with the domain in order to make the inverse a function of x? And we kind of talked a little bit about that before. Just in this previous example. So watch carefully. This black parabola right here is the inverse of this red one. Does everyone see that? It's a reflection about this line y equals x. We're a little bit off there, but you get the picture. Here's the function. Here's the inverse. Now what we determined just before this in our example was the 2 parts to the inverse. That would be one part there, and that would be the second part. Now each of these are inverses, okay? Each of these are functions, but they're only part of the entire kind of big picture of the inverse. So when you get a question like this, what you want to do is you want to try and make the graph or the parabola not a 2-to-1 graph, or one that doesn't fail the horizontal line test and pass twice. Okay? So really what we're doing is we're trying to say, if I got rid of sort of half of this parabola, like this one right here, I would actually get rid of half of its inverse. So if I specified the domain of the original function, and here is the specific domain, if I said this is positive 2, if I said for f of x, if the domain was x less than or equal to positive 2, that would give me just this half of the parabola, and then as you see, the inverse would be a function. Okay. Now, that's not the only way you could restrict the domain. I'm going to just back this up here a little bit so I can get my drawing back. If I can. Okay. I popped to a different... Oh, goodness. Okay, well, there's your notes from the chapter so far. Where is this example again? Hoo-ha. Okay, here we go. Wow, this is great. Love this technology. So wonderful. Okay, I'm not going to be able to reverse that, I don't think. So, okay, so let's see, watch this. So here we go. So we cut off this side here, and I did that again. I'm not sure why it's doing that. I'm trying to get my cursor down to where it is. It pops back to where the cursor was originally. So if we get rid of this, then we get rid of this one, right? But you could also restrict the domain so that you're looking at the other side. So just, I want to show you this real quickly. If now you said, I want to get rid of this side, okay, and just have this side, guess what? That gets rid of this part of the inverse. So that's, after all that, that's what I'm trying to show you. So you could say the domain also could be specified to say that the domain could be x greater than or equal to 2 for the original function, because that would also give us an inverse that is a function. Okay? All right. So how could you restrict the domain? Just make sure that you take half of a parabola, let's say. Go from the vertex and one way or the other, and then the inverse will be a function. Because if you don't, if you leave it like it is, right? That wasn't supposed to be black. This is going just great. If you leave it like it is, then the inverse will not be a function. Okay? So how can you specify the domain? Make sure it passes the horizontal line test. So just say, I'm only going to consider it on this part of the domain, therefore the inverse will be a function. Okay, so I just wanted to kind of show you that, and your assignment then was up here. And just please take note that number 10 is added for 1.4, okay? So that's all you have to add for this whole class. When you're done this, when you're done all the way from 1.1 to 1.4, then I will give you the review to start working on, and yeah. Okay, any questions?